Hello, my name is Ethan Ashe, and my internship this spring was on chloride monitoring in the Charles River tributaries. So before I get started, I wanted to quickly acknowledge some people that worked with me during this internship. Mari Lima, the internship coordinator, Emily Walton, BU Urban coordinator, my advisor, Professor Demerit at Boston University, everyone at CRWA. And then I also want to take a moment to recognize the Massachusetts, the Wampanoag, and the Nipmuc nations as the past, present, and future caretakers of the Charles River watershed. So the issue that we're primarily focusing on is the salinization of the Charles River and its tributaries. So the graph you can see on the right basically is showing you that across the nation, uh, conductivity is increasing, which is a measure of water's ability to pass an electrical current. It increases with the amount of dissolved ions, such as salts, that are in the water. And the reason this matters overall is because salt in freshwater streams can mobilize heavy metals from the soil, and they also diminish the function of primary producers and create toxic conditions for wildlife such as invertebrates, amphibians, and fish. And it also has a monetary damage on infrastructure. So in a paper in 2011, she estimated that the cost to infrastructure was $615 per ton. When you consider that the US used 20.2 million tons in 2007, that's a lot of money. The picture below is from outside of Fenway Station, which shows you the salt coverage over the walking path, which is probably a little too much. So, using this conductivity measure, we can calculate exactly how much chloride is in the water. So, like I said, conductivity is the measure of water to pass an electrical current. From that, you can calculate specific conductance, which is just conductivity at a specific temperature, 25 degrees Celsius. And then using an equation from mass to EP and EPA, you can then convert that to chloride concentration in milligrams per liter. And this correlates really well, as you can see from the graph on the top and then the graph on the right, or sorry, not on the right, on the bottom, which shows some of the live data that we collected from this past season. And then from this chloride data, you can make inferences on if the water body is impaired. If it is above 230 milligrams per liter per hour, then it is acute impaired, and if it is above 860, then it is chronically impaired. So the research questions that we're asking is, do streams in the Charles River watershed exceed these chloride thresholds? And how does chloride concentrations change temporally and during storms or snowfall events? Our methods, in the graph on the right, you can see the locations that we picked for monitoring this event. You can also see an image of our shuttle that collects conductivity data live every 15 minutes from each of these points. Um, we used an upstream and downstream location, and my internship focused on going into the field and pulling these shuttles and monitors and collecting the data using a separate shuttle. And this is some of the data that we were able to collect from it. The blue line on the graph is the chloride readings. As you can see, they spike at certain points that you can correlate to a certain time of year in Boston when snowfall and snowstorm events happened. The yellow and red horizontal lines on the bottom are our acute thresholds, the first one being chronic, and then the second one being the acute 860 milligrams per liter toxic threshold. So as you can see, yes, it is definitely exceeding it at multiple points. But then the green vertical lines show where peaks in the chloride readings happened. And you can correlate this directly with days where precipitation or snowfall occurred the night before. It is still relatively early in the morning at 6 a.m. And there is about to be a drop in temperature. So basically what this means is it is correlating with when snowplow trucks are getting out there on the road and they're spreading salt. This is when the peak in chloride in the streams is happening. So some of the conclusions we can make from this, do streams in the Charles River watershed exceed chloride thresholds? Yes, absolutely. The concentration varies depending on weather, temperatures, and nearby land use habits, but there are days when exceedance happens. How does chloride concentrations change temporally and during storms and snowfall events? So as the Muddy River shows, chloride concentrations increase with rain or snow events, especially in preparation for snowstorms. Then how does land use habits and impervial surfaces affect chloride concentration in streams? So the Muddy River is one of the locations that's very central to Boston. So as the greater impervial surface cover increases, um, you experience higher chloride levels than you might see in other areas like the Bogastow River or the Stop River. And from this and from the internship and the data that we collected, we can make future management implication decisions and policy changes. So from using this data, we can assess impairment status for chloride in streams in other areas and compare them to the data that we collected for this event. We can also inform local Department of Public Works, Massachusetts Department of Transportation, employees if their salting techniques are deteriorating the freshwater streams, depending on how impaired the freshwater body nearby them is. And it can also lead to the adoption of new methods, such as using brine instead of rock salt, using sand where it's appropriate, or alternative, less harmful salts such as magnesium chloride or calcium chloride. Thank you very much.